All right, hello. So today we're going to do unit 4, lesson 4, and we're going to be looking at function notation and how we can use that to solve problems. So first thing I want you to do is to look and see what you notice and what you wonder. All right, so some things you might have noticed were there are 2 columns in each table, so we have a list of x values. But on the other column, we don't have a y. Instead, we have a function. And last week, you learned that that's in function notation. You can tell if you take the first x value, 1, and you input it into the function. 10 minus 2 times 1 is 8. Same thing with all of the additional values. If you put in 5, 10 minus 2 times 5 is 0. So the corresponding number in the y column, or the column with the function, is the result of plugging in the input. Same thing, we have 2 different functions. The first table is function f. The second table is function g. So they have 2 different names. All right. We can look at this as a machine. So having an input, you're putting something in, doing something to it. In this case, we're going to cube it, and then you get the output. So if I have 0 as the input and I put it into the function, I'm going to cube it. So 0 cubed, and that's equivalent to 0 times 0 times 0. And that equals 0. Same thing, if we do 1, we have 1 cubed, which is the same as 1 times 1 times 1. And so that equals 1. Go ahead and try 3. All right. 3 cubed is just going to be 3 to the 3rd power. It's 27 because it is 3 times 3 times 3, which 3 times 3 is 9, times 3 is 27. And the last one, if we have x and we're putting it in, we're cubing the input. If it's a variable, it's just x cubed. So now we need to write the relationship as a function notation using the function name as function g. So it would just be g of x equals x cubed. So we're taking the input, which was x, and the output becomes x cubed, because that's what we do to get the result we're looking for. All right, so what I want you to do here, we're going to go over the matching, and this is on your slide. So if you have them open, go ahead and try to match these on your own. So for the first one, we've got function f. We would interpret that as multiplying the input by 3 and then subtracting by 7. So we're subtracting the result by 7. Function g, we're subtracting 7 from the input and then multiplying by 3. Function h, we're going to divide the input by 3 first and then subtract 7. And function k, we're going to subtract 7 from the input and divide the result by 3. So all 4 of these functions have the same values, 3, x, and 7, but we're doing different operations in different orders. Okay, so one thing we want to do is decide when the input is 6, the output is -3. So which function would that be? And so for us to be able to do this, we need to evaluate these functions at 6. So for us to do that, when we have an input and our input is 6, we can evaluate that by replacing the x with the number we want to evaluate. So for function f, we would have f of 6, because 6 is our input, and we're just going to replace this x in the equation with 6. So we have 3 times 6 minus 7, and we can solve it from there. Our left side doesn't change. It's still f of 6. It tells us that we're evaluating the expression at 6. So 3 times 6 is 18 minus 7. So f of 6 is equal to 11. Let's try g of x. So g, and we want to plug in 6, so we're evaluating it at 6. And so we have 3 times 6 minus 7. So you always start with what's in parentheses. 6 minus 7 is -1. So we have 3 times -1. So g of 6 equals -3. And that is the function we're looking for, is g. And we explain that we know that because plugging 6 in as the input into the function results in an output of -3. For the next one, we want to evaluate each of these functions at 0 and 10 to see which one is the largest. So if we have f of 0, we're going to have 3 times 0 minus 7. 3 times 0 is 0. 0 minus 7 is -7. G of 0 equals 3 times 0 minus 7. 0 minus 7 is -7, and -7 times 3 is -21. H of 0 equals 0 divided by 3 minus 7. 0 divided by 3 is 0, and 0 minus 7 is just -7. And the last one, K of 0, we have 0 minus 7 divided by 3. 0 minus 7 is -7, and it's still 3, but it's an improper fraction, so if we turn it into a mixed fraction, we can kind of see it a little clearer. So 3 goes into 7 twice with 1 left over. And so now we can see which one has the largest value, and it would be -2 1/3. Okay, now let's check it out if we have 10. So f of 10 would be 3 times 10 minus 7. 3 times 10 is 30, and 30 minus 7 is 23. G of 10 would be 3 times 10 minus 7. 10 minus 7 is 3. 3 times 3 is 9. Okay. And then we have H of 10 equals 10 minus 3, or 10 divided by 3 minus 7. And 10/3 minus 7 gives you -3 2/3. And K of 10 would be 10 minus 7 divided by 3. 10 minus 7 is 3. 3 divided by 3 is 1. So our largest value here would be f of 10, which gives you an output of 23. So if it's asking you to evaluate a function or which function is greatest when the value is a specific number, just plug that number into the equation. All right, so let's look at this example of a square. It has a side length of 9 centimeters and an area of 81 centimeters. And the relationship between the side length and the area of the square is a function. So we're going to complete this table and write a rule to represent the function. So if we think about how we get from 9 to 81, well, you should remember how to find area. It's length times width, and we have a square, which means every side is the same. So you're just multiplying 9 times 9 to get 81. A faster way to do that, since it's a square, is to square it. So 9 squared equals 81. So let's fill in our table. We have 1. 1 squared is going to be 1. 2 squared, 4. 4 squared, 16. 6 is 36. And then S, so for any side length, we would just square that number. So that helps us if we're writing the function, and our function name is A, that will give us the area in square centimeters when the side length is S. So to write that, we would have A of S equals S squared. What would A of 2 represent in this situation? Well, a of 2 just represents the area of the square if the side length is 2. And so if the side length is 2, the area would be 4 because 2 squared is 4. Okay, and here's a graph that represents this situation. You can tell that this is a function. It has a pattern, and we're increasing, but it is not linear. So functions don't always have to be linear. This is a quadratic function, which we'll learn more about later on. So now we have a roll of paper that is 3 feet wide and can be cut to any length. So I want you to try to figure out what the perimeter of this roll of paper would be if the side length is 2.5, 1, 2, 6.3, 11, or L. All right? And try to write the rule for the function as well. Okay? You should have gotten these numbers. So if our length is 2.5, we would know that the other two sides were 3, and so that gives us 6, and we just have to add 2.5, okay, to give us 11. 1, you get 8, 2, 10, 6.3 is 18.6, and 11 is 28. And so our rule here, if we had any side length, we would have 6 because the top and the bottom, or the width of that roll of paper, are 3 feet. So 3 feet plus 3 feet is 6. And then we would add 2 times the number of the side lengths of the other two sides, because perimeter is just adding up all of the side lengths together. So our function here would be P of L equals 6 plus 2L, because our input would be L, and our output is what we do to get the perimeter, 6 plus 2L. So in this situation, what does P of 11 represent? Well, P of 11 simply represents the perimeter of the paper when one of the side lengths is 11 feet, and it's 28, because we have 11 on 2 sides, and then 3 on 2 sides. So 6 plus 2 times 11 is 28 feet. All right, here's a graph to represent this. So it is increasing at a linear rate, and you can tell because we have no exponents in our equation as well. All right, so hopefully this helps function notation make a little more sense to you, and you understand that we can see those values in tables and kind of see them on a graph as well. But when we're evaluating a function, we're simply taking a number as the input and replacing it with the variable in the expression to solve for it.